So the key thing that's going to be important in this paper, right, is that there's a key border, and over here, if you were over here, you had to send 1/7 of your labor to work in the mines, and if you happen to live over here, that was not true, right? And so why is the border important? Why is the border important? Yeah, Jack.
It's a discrete boundary.
Exactly, it's a discrete boundary, and so say more about that.
Yeah. So on one side, there's a very strong, as you were saying, 1/7.
Right, and why do we care about the fact that it's discrete?
Because it allows you to differentiate between places in which all other factors would be more continuously varying.
Exactly. So the idea is that the stuff in the world varies continuously. This policy change is discrete, and so we're looking at one side versus another to sort of see the effects. Okay, and so that's going to be that's called a regression discontinuity design. How many of you have seen regression discontinuity before? Few, not many. Okay, so I'm gonna go through that in a fair amount of detail today. This is sort of this design, what's called regression discontinuity, is kind of another one of our key empirical toolkits. Or more generally, so what's the hypothesis of this paper? Okay, so she wants to study the Mita, and she finds it was bad, and what's the idea for why? Or why might you think this would be bad today? Yeah, Rebecca.
I think she thinks it's bad because they study both stunting children and lack of consumption.
Yep. Yeah, no, exactly. So it's clearly bad, right? So she's going to show you that it's clearly bad. Children are stunted in these areas. They have less consumption. Clearly, being in this area, being in an area that was under the Mita 200 years ago is clearly bad for you today. Right, that's the argument. But I guess the question is why. Okay, so right, so over here there was roads, there was private land. This is in particular the large ones, the haciendas, right? What else? Do you have other things she talks about? Yeah, Maya.
I think she mentioned that in the non-Mita areas, they had even after the policy ended, people were more likely to be subsistence farmers. They had less time in the past to invest in their own land and their own resources.
Right. So lower investment, land. Now this one you might think they might have done at the time too, right? Because it might be that you don't want to invest a lot in your farm if you're kind of prime age male laborers going to get sent away to work in the mines. You might do other things, right? So that may have been at the time of today. Any other stories? Some other ones that we didn't necessarily mention is trust in institutions, right? So one other idea is again, in the same way that we talked about the slave trade last time, the idea that they're about to sort of grab. She doesn't talk much about sort of how exactly the local native elites figured out who was going to be the conscripts or who wouldn't. But you could easily imagine that if 1/7 of you have to go away and work in the mines, and there's some local boss who's coming around sort of grabbing people, that could undermine trust in your institutions, trust in your leaders, trust in each other. You could create incentives to denounce each other. This could also be bad in the same way. Another one that you guys didn't mention, but also is outmigration. So trust. There's another one, outmigration. Right, so certainly if I'm living over here and there's any way I can get over here, I might want to do that. Right, so there's a bunch of different stuff, okay? And some of these may have been persistent, some might have not been persistent. And again, I want to come back to sort of what we think we can learn about this causal pathway from this kind of exercise before. But she's going to show you that sort of all of these basically change. Okay, and that's something that's pretty remarkable. Okay, so I want to pause on the substance for a minute and just talk about the methodology, and then I want to come back in 20 minutes to the substance of this paper. So just pause for this for a second. Okay, so what is discontinuity bias? So the idea is lots of things in the world with whatever these cutoffs are, right? Whatever this particular cutoff is, age, vote share, whatever, test scores, lots of things in life vary with those things. Okay, but they tend to vary continuously. Okay, so if on age, for example, we like to think you become maybe more mature as you age, right? So in general, 22-year-olds should be more mature than 20-year-olds, but hopefully not just continuously, right? The idea is that all the other sort of stuff in the world is supposed to vary continuously with your x variable, except for our treatment, which changes very sharply at the discontinuity. Okay? So the idea, you can legally buy alcohol when you turn 21, but your maturity should grow continuously as you age. Okay, that's the theory, right? Okay, or better politicians running for governor get more votes, right? And we'd like to think that was true. But there's a huge difference between getting just one more vote than your competitor and getting one fewer vote, right? In that one of you becomes governor and the other does not. Right? So that's the idea. Okay. So the technical assumption that we're looking for is this. Okay. So remember, this is a notation which I think I defined earlier. Okay. Yi of 0 is the outcome you would get if you did not get the treatment. Okay? So yi of 0 is the outcome y for individual I. If 0 if they did not get the treatment, yi of 1 would be the outcome if they did get the treatment. And of course, the general trick in life is that for any individual I, we only either see yi of 1 or y of 0. They either got the treatment or they didn't get the treatment. So the whole kind of name of the game in all of this econometrics is figuring out the one that, inferring the one you didn't get to see. Right? So if I was treated, you see my yi of 1, we'd like to figure out what my yi of 0 was. Okay. So the assumption is, in the absence of the treatment, the yi is of 0, if I take the limit as I approach the cutoff c from above, and I approach the cutoff c from below, that should be the same. Okay, so if I was to draw this, okay, right, this is c, right? What I'm saying, and this is yi of 0, what I'm saying is if I approach this limit from above and approach the limit from below, I get the same answer. Okay, that's all that says. Okay, so that's the key assumption that's going to identify things in a regression discontinuity. Okay, in the examples we were talking about a few minutes ago where I said, well, that one doesn't necessarily work because other things are changing, that was what I was saying was, well, gee, in some of those other examples, other things might change as you approach the discontinuity from above and below. So for example, if in the example where like a law changed on January 1st of a year, right, and we're thinking of other outcomes, the question is everything else, except for that law, is everything else the same kind of as we come up to January 1st from above and below? Okay. All right, so that's the assumption. Is this clear? So the way this paper works, as I mentioned, is it takes advantage of the fact that the Mita had a well-defined border, right? Okay. So here's the map. So this is the map of Peru, basically. Okay, and the black area is the Mita. Now, if you remember, does anyone know what the white area in this picture is versus the black area? Earlier, the reason we want a boundary is we think that stuff is sort of, other stuff in the world should be kind of smooth across the boundary, sort of similar on both sides. And just because you have a boundary doesn't necessarily mean that things are smooth on both sides of the boundary. If I drew a boundary right at the border of the Charles River, it would be dry on one side and wet on the other side, and that wouldn't be, all else equal, right? And likewise, these boundaries, if you look at a lot of them, they kind of, and this is an elevation map, this is on a plateau, right? You can see a lot of them sort of right at the edge of the plateau. And if you start moving over either side, on one side you're still on the plateau, the other side you fall off the cliff, right? So she chose the areas primarily in the middle here where the boundary sort of meanders away from the border of the plateau and sort of things look more even on either side. Okay, so that's where she's going to study it. Okay. Okay. So as I said, this is a general example of what we call regression discontinuity design. So I'm going to show you how this works. Okay. So in general, regression discontinuities are useful whenever you have a case where a treatment, any treatment, is assigned based on some strict threshold. Okay? So in particular, like we would write it, if your treatment of whatever is equal to 1 if some variable is greater than some cutoff, and 0 if it's less than some cutoff. This is in a single dimension. This paper is actually a little more complicated because the discontinuity is in 2 dimensions, but we can imagine this in a single dimension as well. Okay? If you're above this cutoff, you get 1. If you're below this cutoff, you get 0. Okay, so can you guys think of examples of sharp discontinuities in your life? Yes, Pat.
One of the things I had seen before was like admissions based on test scores.
Yep, absolutely.
So you have to like get over a certain threshold.
Yeah, so that wouldn't work at MIT, for example, right? Because because seriously, because you guys have lots of stuff that goes into your application. There's like your test scores and your high school GPA and those letters of recommendation and a whole bunch of stuff. And your test scores are positively predict your admission, but it's not a strict threshold. But other places, like where they might have a strict rule.
I think it was New York City public schools.
Yes, exactly. So some of the exam schools in New York. Is anyone here from any of the New York exam schools? Right. So the New York exam schools, right, basically have a test and they take the top X people on the test and that's it. Right? In fact, there's been a lot of controversy on that point, but that's how it works. And in that case, exactly, if your score is just above the test, so if you got a 64.21, if that was the threshold, if you had a 64.42, you got in, and 40, you didn't get in. Those scores are approximately equal, but one of you gets to go to Stuyvesant and one of you doesn't. Right? So that's an example. What are some other examples? Yeah, Sebastian.
Poverty programs that conditional on your income, you receive
Yep.
or not receive a transfer.
Exactly. So some of them work exactly that way. So if you're lots of them actually. So some programs in the U.S., for example, have income eligibility thresholds. If you're below some 120% of the U.S. federal poverty line, you get the program. Above it, you don't. Developing countries work that way on what is called predicted income. Some of the programs work exactly the same way. What else?
Sometimes a law is enacted in a particular year.
Okay, that's a little more complicated, but yes, laws could take effect at a particular date. So that depends on whether you can really zoom in on the threshold and whether other things are also changing at the discontinuity. So one of the challenges with using a time-based discontinuity is that often lots of stuff changes, like on January 1st, lots of stuff changes in the new year. So it'd be hard to know that this and only this changes. But sometimes you can do stuff if it changes on something changes on a kind of a more obscure date, and you can argue that nothing else important happened on October 3rd. In this particular context, you can try to do that in time. Time's a little trickier. Yeah.
I don't remember exactly, but I think it was that below a certain birth weight, babies went into intensive care.
Yep. 2,500 grams, I think. Exactly. Cullen?
Say nations that disenfranchise based on felony conviction.
So that's a little harder, and the reason is this X thing has to be continuous. So in that case, felony or not felony is kind of a discrete variable too. So you could maybe think of some way to generalize that, but that one sort of, it's like, yes, you're disenfranchised. It's discrete whether you're enfranchised or not, but it's also the underlying X variable is also discrete. Do you felony or not? So this thing has to be continuous. Yeah. Oh, no? Go ahead. Yeah, sorry, you don't think.
Sorry.
Oh, I can't see it. Anna, yes.
Like state laws, if you were to look at counties like right along the border, maybe there's a difference in minimum wages.
Yes, exactly. So in fact, the famous paper on the minimum wage is New Jersey versus Pennsylvania, which was state differences. But yeah, that would be an example of a two-dimensional RD. Now, those geographic ones are also tricky because, again, you have this question of what you want. So what's not written on the board is you want the treatment to vary at this cutoff, and you want nothing else to vary at the cutoff. So the concern about those geographic ones is, is there something else besides minimum wage varying at a county border? Property taxes, schools, like lots of stuff also potentially varies. Other examples? Anyone I haven't heard from today yet? Yeah.
Age limits?
What's that?
Age limits?
Like what?
So like, I guess legality of like when you become 18, like there's all these legal statuses that change, or when you're 21, like you can drink.
So 21 actually may be a better one than 18 because so many things happen at 18. Drinking is probably the main one at 21. Maybe there are other ones. You guys are closer to 21 than I am. But yeah, no, exactly. Age limit. In fact, that's actually the example I have on the slide. Other ones? Okay, so yeah, go ahead. One last one.
Writing a ride at an amusement park.
What, sorry?
Writing a ride at an amusement park.
Yes. I'm hard to think what the ultimate outcome of your decision is, but yes, absolutely. My daughter was very pleased when she became 48 inches and could now qualify for all the good rides. Okay, so right. Okay, so here's some I had. You guys had sort of similar ones. Oh, except you missed a very, very, very common one, which comes up a lot in this class, which is elections are discontinuity in the vote share. Okay, so you win if you get one more vote than the next person, right? So who the winner of an election is discontinuous in the vote share, and that's actually super useful for studying politics. Let's see, Medicare when you turn 65 is an age one, test scores another age one, etc. Okay, so those are examples of how this, and you can see it quickly comes up a lot, right? It doesn't come up in all contexts. But bureaucracies, for whatever reason, tend to love these discrete rules, and so that tends to be very useful for economists trying to study them. One thing to note that's really important, when I defined the RD, I wrote Ti is equal to 1 if xi greater than c, and equal to 0 if xi, I think I did it this way, less than c, okay? This is an example of what's called a strict discontinuity, meaning the treatment changes for sure when you cross the threshold. Turns out we actually don't need this to hold for sure, okay? And most of the cases in the real world, it doesn't actually hold for sure. So for example, let's go back to our drinking example. So, that's supposed to be a less than, right? It might in fact be the case that some people below age 21 were able to get access to alcohol. Right? That might or might not be true, probably is. But the idea is that the ability that you have to get access to alcohol is going to increase discontinuously at age 21. Okay? Right? It certainly becomes discontinuously easier to buy alcohol when you turn 21. Okay? So suppose I wanted to do a study where the outcome variable was, did you, buy a drink last weekend, right? And I was to graph, right, probability you bought a drink last weekend, probability drink, right, as a function of, age, and this is, 21, right? It would probably look like, there were people who were below, this would be not 0 over here, but it would probably jump up discontinuously over here, okay? Because those are the people who can buy legally once they're 21, right? Or any of these examples, right? Or many of these examples, I should say, have this feature, okay? So in that case, what we want to study is this difference that occurs right at the cutoff, okay? All right, and this is called a fuzzy regression discontinuity. And it's fuzzy because the treatment assignment is not my this was the sharp discontinuity, where for sure the treatment varied at the cutoff. And more generally, what we actually require is what's called a fuzzy discontinuity. And here we require the following. So now Ti is the treatment variable, okay? And I'm going to take the same limit approaching C from above and below. And the key thing is that the limit from below and the limit from above are going to be different. Okay, so that just says that if I draw this picture, this is the limit from above, gets me here. This is the limit from below, gets me over here. Okay? So combined, that's what buys us that discontinuity. It's that if I did this in the yi zeros and the counterfactual outcomes, they should match at the discontinuity, right? What would have happened in the absence of treatment should be the same if I approach from above or below. But the treatment has to be different depending on whether I approach the discontinuity from above or below. It has to jump discontinuously. Okay, so that's the key assumption. Is that clear? Is the notation clear? Okay. All right. And here we're just going to use this. This is just basically saying there's a discontinuous jump in the treatment probability right at the threshold. Okay. Now, how do we do this in practice? If you were actually to open your computer and try to implement a regression discontinuity, what would you do? And the answer is, we can't just compare people over here and people over here. And the reason is we know that in general the people on this side are different than the people on this side. They have higher values of X. They're older, they got more votes in the governor example, whatever, they're different. Okay? We only want to look at the people, or this whole thing is only helping us right at this discontinuity here. So what we have to do is we have to estimate a regression equation that looks like this. What is this? This is our outcome y. This is a dummy variable. Remember, that's a 0, 1 variable that captures, are you on the right of the discontinuity, or well, one side, generally speaking, the right. This is for the right. And this is f of x is saying it's some very flexible functional form of x that captures however stuff in the world happens to be changing continuously with x. Okay? So that's what this captures. Is that clear? What people always do is they should, the question is how much of your data should you use? If I'm interested in sort of the effect of turning 21, I don't want to use 38-year-olds in that regression, right? But where do I draw the line? I clearly want to use the 21.1-year-old, but do I want to use 22-year-olds? How about the 23-year-olds? How about 23.5-year-olds? What that's called is the bandwidth, okay? So typically what I do is I say I'm only going to estimate this thing in a direction of the bandwidth. Now, of course, if I have infinite data, right? If I have infinite data, the bandwidth is 0, and I literally just take this limit. I don't have to worry about this f stuff. In the reality, we have finite data, so we have to use finitely large bandwidths. And then there's a question, again, of what the optimal bandwidth is, and there are some theorems for what the optimal bandwidth is under certain conditions. What most authors you'll sort of see is they'll report different bandwidths. So actually, in fact, skipping ahead to the Dell paper, you'll see columns like this, where she actually shows you different bandwidths, right? 25, so she 25 kilometers, 50 kilometers, 75. So she's showing you what happens as they get closer and closer. And that's exactly sort of saying, look, you know, I could do it this way, I could do it that way, it doesn't really matter. And the other thing she does is she says, how should I specify f? Well, I could do it this way, I could do it this way, I could do it this way. These are all different versions of how do I specify that polynomial, that functional form f. And so what most people end up doing is something like this, which is they sort of say, well, you know, I'm going to show you some reasonable choices of bandwidth and some reasonable functional forms for f, and I'm going to show you I get kind of similar results, and then you're going to believe me. So now we can talk about her paper. And I said that's going to come up a lot. And then the final thing, I didn't actually say this, but in the final thing, to sort of put everything together, if you actually have a fuzzy discontinuity like this, you can actually use instrumental variables or like a wall estimator, like we learned about last time, if you want to estimate the effect of the treatment on an outcome, right? And being on this thing over here, being on one side of this continuity, that's our instrument, right? So that was the idea. So then we can say, well, I want to look at the impact of drinking on exam scores, right? And my instrument for whether you were drinking is whether you're 21 years old. So I'm going to set this up as an instrumental variable where my x, my endogenous variable in the IV sense was, did you drink? My instrument is going to be, is this a dummy for you above 21? I'm going to control for these like f of x's, and I'm going to set the whole thing up as a wall estimator. Okay, so it all kind of comes together. Okay, other questions? Yeah, Pat.
So for the last two technical assumptions, it's still required that the only thing that changes over that border is what you're trying to investigate, right?
Yeah.
Okay.
This you mean?
That's included in that. Okay.
No, that's not included in that. It's still maintained.
Okay.
Yeah. So like this is always the maintained assumption. This one is the maintained assumption, always. And then I'm saying, but what's not required is for the thing to jump, is for it to be a guaranteed function of treatment. It can also be this like fuzzy treatment here.
Okay.
Yeah. But you always need this. Okay, clear? Great. Okay, so now back to the Mita paper. So in her case, what's x? How do we set this up in an RD framework? Yeah, Rebecca. Huh? So it's kind of a trick question. It's 2 dimensions, so it's a little tricky, right? But say more. Someone else want to try?
Wasn't it the distance from the Mita?
Yeah, so she's going to do it as distance from, so the reason this is a trick question is, in some sense, this is like the worst paper to start teaching IV with, but it kind of comes in the natural place in the sequence, which is why I do it. And the reason it's not a great paper to teach IV with, or it's a tricky paper, is actually this is all now going to be in 2 dimensions. Right? So if I had started by teaching you an lecture, like a paper on voting, and I said, well, we're going to look at who got the most votes, and that's going to be our thing, that would be a little bit simpler. In this case, a little bit complicated. So in her case, actually, so we're still right here, over here, right? Here's the border, okay? And you can think of X in her case as like anything that kind of varies smoothly like this. So you could think of X as like a 2-dimensional X, right? It's like latitude and longitude, for example. So you could imagine that what I want to control for in my f of x is some surface in latitude and longitude, which is capturing how sort of stuff differs arbitrarily as you kind of move smoothly across space. So that's one way to do it, is to actually think of x as like latitude and longitude. Another way to do it, I don't remember who gave me that answer just now, but another way to do it is to collapse into a single dimension and say I'm going to do it as distance from the border. Distance from the border, right? This is distance from border, where this way is outside, and this way is inside. Right? And that's the border. That's a way of kind of collapsing it onto a single dimension. And either of those can work. But the general idea is we're going to try to kind of come up with a way of using this x notation in this 2-dimensional context. Okay. Okay, so is that clear? So in her case, the way you should think about it is like, I think the way I like to think about it in this paper and similar spatial papers, because we're going to look at another spatial paper later. So when I think of similar spatial papers, is the world varies continuously in 2 dimensions, right? So we could write a function y equals f of latitude and longitude, right? That's some like 2-dimensional surface that captures how the world smoothly varies because we move across space, and the border is going to be some discrete line we draw through that. Okay? All right. So here's again her map. Okay. So as I said, it's a little tricky, blah, blah, blah. She does it in 2 ways. She does it distant, so what she'll do is she'll like estimate some kind of polynomial latitude and longitude that's like latitude times longitude squared, longitude squared. That'd be a 2nd-degree polynomial. Cubic, we could do it's all the 3rd level in terms of all those things. It's basically some flexible way of sort of estimating what that surface looks like. Okay, or move it down to 1 dimension and do distance to the border. Sorry, distance to the mine or distance to the border? Distance to the border is probably better, actually. Distance to the mine is a little bit trickier. And then the other thing, as I mentioned before, she's going to zoom in closer and closer to the border. That's this idea I was saying over here of choosing closer and closer bandwidths. Okay. Okay. Yeah, Sebastian.
I guess this type of analysis, spatial analysis, requires super specific data.
Yes.
How was she able to collect that data?
It's like amazing. Okay, we're gonna come back to that. No, that's why this paper is like so cool. So she actually has to get all this different data and map it spatially. And actually, the paper that I did, the paper that she and I wrote together, which I'm going to talk about next, has like even more like unbelievable spatial data. Like but we took villages from 150 years ago in Java and like found them on the map today. So like. But you're right, it requires super detailed microdata that you have to be able to identify. So, yeah, so, but also on the other hand, in this paper, her bandwidth is going to be like 50 kilometers, which is still small, but it's not nothing. In the paper that I'll show you that we did more recently, the bandwidth is like 3 kilometers or 5 kilometers or something. So it's like really small. Yeah.
Are the location variables at the village or city level?
Yeah, they're at the municipal level. So she's going to take the municipal centroid for a lot of them. Yeah. Okay, other questions? All right. So, okay. How would you check this is a good empirical design? What might you want to look for?
The proportion of people going to Mita is much higher within the board.
Exactly, right? So one thing we want to know is one of the treatment varies discontinuously. That's right. That she actually just has to get from her administrative data. Matthew, what else?
You want to make sure that everything else is continuous.
Right. So you want to also look for that everything else doesn't change. So there's some stuff that might be affected from the treatment. The problem with the challenge with having a treatment that happened 200 years ago is most of the stuff is beforehand, right? But there's some stuff, most stuff probably happens after, but there's some stuff that might be not affected by the treatment. You want to check that stuff all looks similar on both sides of the discontinuity. So does anyone remember examples? So she does this in the paper. Anyone remember some examples? So that's quite remember examples? No? Rebecca, you say
Elevation.
yeah, so she checks elevation. What else?
Ethnic composition?
Yeah, she does check percent indigenous. I guess her argument is that it didn't move. Other stuff, yeah.
Pre-existing settlement patterns.
Like what? So does anyone remember what she does actually? What she does check? About pre-existing patterns? She actually finds this from the Spanish archives, an economic census that was done in 1572, which was the year beforehand. That's not a coincidence. They were trying to sort of figure out kind of what was where when they set up the Mita boundaries. And checks in the 1572 economic census from like 500 years ago that in fact it looks pretty continuous across the borders in terms of kind of what economic activity was. And that's about it. So that's what this looks like here, right? So we have elevation, slope, percent indigenous, whoever said that was right. The log 1572 tribute rate, that's one of my favorite variables. Percent and where that tribute was going to. Percent going to the Spanish nobility, Spanish priests was 1572, so stuff was a little different then. Spanish priests, justices, indigenous mayors. Okay, and that's about what she has. Okay, now, so what she does is she says, well, here's the meat outside, here's inside, and here's sort of whether these differences are statistically significant. And you see, for example, there are some differences pretty far out, but as you move closer and closer to this continuity, those things become less significant. They look like they're more balanced. Okay? And in general, whenever you see a balance table, so whenever you see a regression discontinuity, you usually see some table that looks like this, which says, look, I'm going to take a bunch of stuff that shouldn't change, and I'm going to show you they look similar across the discontinuity. The other thing, which she doesn't do in her paper, but I'm just sort of worth mentioning, is the example I gave you about the 2,500 grams is a general test that people often do. And that is, if you look at the discontinuity, you look at the x, and here's the discontinuity, you just literally kind of plot a histogram of your data. Okay? And what you want to make sure is that the histogram looks continuous at the threshold. Okay? If you find bunching at the threshold, right, if you find that your data looks like this, that's bad. That says that probably people were actually manipulating the data to be on one side of the threshold or another. Let me give you an example. So in the poverty targeting context, there's a wonderful paper about the poverty targeting in Colombia, where they sort of went around to everyone's houses and sort of figured out your assets and gave everyone an asset score. And if your asset score was below some threshold, you got these transfer programs from the government. Okay, that's very common. And what they found was after a number of years, if they just plotted a histogram of the asset scores, they looked like this, right? They had a huge excess mass just below the discontinuity and huge missing mass just to the right of discontinuity. And what they argued was happening was over time, people figured out, maybe if I bribe the enumerator, he'll tell me that what are the answers of what I have to say. Well, I don't have a TV, I do have a dirt floor, whatever. What's the minimum I need to do to just be able to qualify? And so if that's true, you can't run a discontinuity because obviously the people over here look different than the people over here. And so if you ever see in a paper what's called a McCrary test, a McCrary test is a test that the distribution is continuous at the threshold. So if you see a reference to that, I just want you to know what it is. That doesn't happen in this paper because it's geographic, but in a lot of other papers you'll see that. What does she actually find? Okay, so here's the results. So as I mentioned, she has different panels for the way to specify the regression discontinuity. Can someone tell me what should I interpret this coefficient over here to mean? I'm in column 3, row 2.
There's a negative relationship between presence of the Mita and household consumption within 50 kilometers of the boundary.
Exactly, right? So 50 kilometer bandwidth, negative relationship between being inside the Mita and household consumption in 2001, like in the present, and how big is it? What's the size of that effect? Is that big? Is that small? Huh? Big. How big? How do we interpret that number? Yeah, exactly. You're about 32% lower household consumption, right? Is that big or small? Huge, right? Okay, so let's just make sure we understand like what that means. Okay, that means she took those two lines. Here's the Mita, and she drew a bandwidth 50 kilometers wide. Okay, so that's not 50 kilometers, it's about 30 miles, it's not very big, right? And the people over here are 33% poorer on average than the people living just on the other side of this line. 200 years after this institution ceased to exist. Okay, like at least to me, that's like a really big effect, right? That's pretty remarkable. Okay, so that's another reason why it's important to try to interpret the magnitudes when you see these numbers, not just negative and negative in the stars. Like this is a really big number, and it's important to sort of keep that in mind. Yeah, Sophia.
Just to clarify, so that means that if you had the Mita, like today, you're 32.9% less. You have less consumption.
Yeah. So and by the way, in a lot of developing country contexts, we'll use consumption as a proxy instead of income. It's easier in a lot of developing countries. It's easier to measure how much you consume than how much you earn. Particularly for people who are occupied on their own farms, it's very difficult to sort of count, like figure how much you. It's easier to figure out how much you eat than how much you produced. So we use consumption in a lot of contexts. Okay, that's really big, right, Maya?
How would boundary fixed effects be different than just being on one side of the boundary?
Okay, great question. What does she mean by boundary fixed effects? What she means. So this is like pulling together all the things we learned in the last lecture. She's using the within estimator. So what does that mean? So remember, she's estimating like y. What she's actually estimating is like y is equal to alpha boundary segment plus beta Mita plus f of x plus epsilon. Okay. So boundary fixed effects is a dummy variable for being on different parts of the boundary. So what she's doing. So remember in our example with temperature, where we included country fixed effects, that was the same as like demeaning everything and only looking within each country, right? We talked about that last time or 2 times ago. She's doing the same thing. So she's putting it, so if this is the boundary, she's dividing it into segments and putting dummy variables for each of these segments. And why is she doing that? It's like yet another way of saying, of making sure this assumption that everything is the same is really true. She's sort of saying, well, look, over this entire, maybe I want to control for latitude and longitude, but over this whole spectrum, like maybe latitude has a different effect over here than over here. So I'm just going to divide this thing into segments. Within each segment, I'll take out the means and only sort of focus on what's going on in this segment, controlling for some local polynomial over here. So that's what it means. Other questions? Okay. This will get easier as you see more and more of these papers. Okay. All right. So, big effects, right? Really big effects. So then, what she wants to do is start telling you something about the channels through which how this stuff persisted. Okay, so does anyone remember kind of what she's saying? What the point of this table was? Anyone? This is haciendas. Okay, so one of you mentioned it earlier, right? Which is that one of her hypotheses is that the hacienda system, which was sort of these very large kind of agricultural estates in these areas, developed outside of the Mita because they didn't want to sort of, it was very hard, they didn't want to be doing it in the Mita because they couldn't get any good labor because the labor kept getting sent off to the mines, right? So the haciendas are much less likely to occur, in 1689, are much less likely to occur inside the Mita area. There's a bunch of different ways of measuring that. That's true kind of when the haciendas are set up, like in 1689, even in sort of later data after the Mita, but while the haciendas are still there and very active, the haciendas are contributing like less tribute or whatever in 1845, kind of in the Mita areas. Okay, and they have and even in 1940, in most specifications, you have a smaller percent of the people are living on the haciendas in 1940. Okay, so one thing that seems to happen is that sort of the patterns of agricultural development are different. She also finds education is less in the Mita areas. She also finds that roads are less. Okay, there are fewer roads in the Mita area. I'm going to go a little faster now. Okay, fewer roads, worse roads, etc. Okay, so what does she show? Okay, she showed that stuff is much worse in the Mita area today, and she showed all these different things kind of in between. There were fewer haciendas, fewer public goods like roads, less education, less income today. She also showed that there was more likely to have shining path violence inside the Mita today, which is sort of a insurgency group that was active in the, I guess, 80s, 90s, 80s. Okay, so how does she try to weave this all together into a story? What's the kind of overall story she's telling? Part of it could be migration. She also focused on sort of less development, right? That these guys were sort of pro-development, right? So the way I think of her story is sort of something like this. The Mita was there, that was bad. The haciendas decided they didn't want any part of this, so they set up kind of this big, large-scale industrial development outside the Mita area. Those haciendas became quite powerful. They both developed public goods themselves, and they invested in the public goods themselves. So, for example, they built a lot of roads. Even as the haciendas no longer became important, the roads were still there, right? Because roads tend to be where the road, if any of you who live in Cambridge, which is, I guess, all of you, the roads in Cambridge and Boston follow, old cow paths from 300 years ago. Roads are very persistent. So these roads are persisting. The roads in themselves could be important for income. Income could buy you more education, right? Then the education in turn could buy you more income, and so on. So there's kind of a story that kind of goes this way, okay? And that sort of gets a lot of the sort of items we talked about in the beginning kind of into a sort of a thought exercise. Now, one thing that's important to point out, though, is she doesn't really have any way of showing, like that's the story she tells, but what the paper is showing you is just there was the Mita, and in the Mita area, all this different stuff happened. And I tried to sort of weave one story. Mita led to the haciendas. Haciendas didn't lobby for the roads. Roads didn't lobby for education. Maybe you can tell a different story. Maybe, in fact, that what happened was the Mita Mita killed local trust. You can't run a big farm if nobody trusts each other. So the haciendas said, I don't want any part of that, because of the trust issue. The roads, the trust was useful for commerce, and it was commerce in general that was important for the demand for roads, and so on. So that's a totally different story, kind of based on trust. We can't really know which it is, right? What this paper kind of is doing, it's moving us forward by saying, look, this thing happened, and I can show you the effects all the way through historical development. But what particular channel of sort of which of these different things caused which of these other things, we don't really know. We just know that all these different things are the consequence of this one policy. Is that clear? Right. It's like we have one treatment, and sort of we can see all the different outcomes of that treatment, but we don't sort of know which of the various outcomes caused each other. And that's also very common in a lot of these papers. Sebastian, yeah.
So in this sense, there wouldn't be scope for policies, like spatial policies to counteract this?
Depends on your theory. If you thought that in the end of the day the only stuff of this that mattered today was the roads, you would build more roads. Yeah. If you thought that actually no, it was the trust, there would be no. So it depends on your theory. So actually, it's a really important question for understanding what the impacts of this are. For understanding it like as a historical phenomenon. Okay, so I think this paper is super useful for understanding how can it possibly be that this institution that ended 200 years ago still has persistent effects? Well, I think she shows you all this stuff that happened in between, so you can easily start telling stories for how this stuff could have affected it, how it could have lasted so long. So that's why I think it's useful. As a policy matter, I think it's much less useful, because what you would do depends on whether you think today it's really about education or really think about roads or whatever. As a policy matter, I would say, well, I want a different study to understand the roads and a different study to understand education, and then I would try to go from there. So I don't think of this as a policy paper. I mean, except for don't do the Mita policy. But we probably weren't going to do that anyway for other reasons. Yeah.
Do you know what kind of reaction this paper pattern be?
I don't know, actually. It's a good question. we have any Peruvian people we could ask? Okay, other questions? All right, okay. So now, this was one example from, Peru in the, I guess, 16th through 19th century. Do you think this is likely to be general? What do you think? Does this tell us about colonialism? Yes? Yeah, Sarah, what do you think?
I think they're likely to be general, but that this is quite an extreme situation where like a large proportion of the population was out of commission, basically.
Right, so it could be these are general themes. Could be this was a particularly egregious example, so maybe you wouldn't get 32% otherwhere, but it should be sort of negative. Other views?
I mean, the paper, like, in a weird view, the paper suggests that this like sort of feudal thing is preferable to like the statewide entire extraction thing that the Mita did, which is like, I mean, it's true, but I don't think anyone would have chosen to be in the haciendas.
Right. It's not like haciendas are awesome, like maybe in the is that what you're saying?
Yeah.
Yeah. Exactly. Right. It's sort of like less maybe right. So one view is lesser of two evils, and sort of like that could be, right? Yeah.
How strong is the memory of it today?
That's a great question. I don't know the answer to.
So that figures into the culture. Maybe the people are telling themselves their own story, and that influences their choices. If they believe, for instance, the deck is already stacked against them.
Yeah, could be. That's right. That's a really interesting question. I don't actually know the answer to that. I have a former student from Peru. Maybe I'll ask him.